So today we're going to start looking at something called quadratic identities, and the definition is that if two quadratics are equivalent, if they're equal, then their coefficients must be equal. So what you'll see a lot in this part is this idea of the taking a quadratic like 3x squared minus 4x plus 1 and then turning it into a quadratic with different coefficients, like a outside of x plus 1 all squared plus b outside of x plus 1 plus c. So you have three coefficients that you need to find. You need to find the a, the b, and the c. So you need to end up with three equations because there's three variables. So the first thing you do is simply equate the two, okay? So we start off with 3x squared minus 4x plus 1 is equal to a outside of x plus 1 all squared plus b outside of x plus 1 plus c. Okay, and then what you're going to do is you're going to expand these x plus 1 all squareds and multiply them by the coefficient. Because when we do that, we're only going to have one x squared term, which we will then be able to equate to the 3x squared. And we'll get one of our coefficients, and then we'll simplify our like terms with the x's and equate that, and then the constants and equate those. All right, so when we expand it out, we get ax squared plus 2ax plus a, and then when we expand out the b outside of x plus 1, we get bx plus b, and then it's all plus c. Okay, so then you're looking at the two sides of the equation, and we can say that on the left we've got 3x squared, and over here on the right we have ax squared, so they're going to have to be the same. On the left we've got the minus 4x, on the right we're going to have the 2a plus b times x, and on the left you've got the plus 1, and on the right we're going to have plus a plus b plus c. So they're the parts that are going to be equal. So we'll start off with the really easy one, which is generally the x squared. It's not always going to be, but generally that's going to be the simplest one to start with. So therefore 3 must be equal to a. Okay? Then we look at this term here, which has to be equal to this term here, because they're the coefficients of x. Okay? So then we have negative 4 is equal to 2a, 2a plus b, but we know that a is equal to 3. So negative 4 equals 2 lots of 3 plus b. So b must be negative 10. So we've got our first two. We know that a is equal to 3. We know that b is equal to negative 10. And then we're going to have a look at the constant term. So you can see up here we've got the 1, and then over here we've got our a, b, and c. So therefore 1 is equal to a plus b plus c. But we already know that a is 3 and b is negative 10. So then we get 1 is equal to negative 7 plus c, and therefore c is equal to 8. Now you found the values of them, you then need to rewrite it. Okay, so your solution down here is 3x squared minus 4x plus 1 is equal to 3 outside of x plus 1 all squared minus 10 outside of x plus 1 plus 8. Okay, now where is this useful? Because that seems pretty airy-fairy and not terribly applicable. But what we use it for are things like this. So if we want to find the equation of a parabola and we know 3 of the points that it passes through, Okay, so we know it goes through the point 1, 6, we know it goes through the point negative 2, 3, and it goes through the point 0, negative 1. So what we know is that the general form of a parabola is y is equal to ax squared plus bx plus c, and we know these 3 points. So what we're going to do is we're going to substitute them in. So first we're going to use 1, 6, and when I substitute that in, I end up with 6 is equal to a outside of 1 squared plus b outside of 1 plus c, and therefore 6 equals a plus b plus c. Okay, so we've got one equation. I'm going to call that equation 1, but it's got 3 variables, so I can't do anything else with it. So let's have a look at the next point. So now I'm going to substitute in negative 2, 3. So straight back into your y equals ax squared plus bx plus c again. So we get 3 is equal to a outside of negative 2 squared plus b outside of negative 2 plus c. And so when you simplify that down, you get 3 equals 4a minus 2b plus c. So there's my second equation, number 2. But 3 variables, we need the 3 points. So my next point is 0, negative 1. Okay, so when I substitute that one in, we get negative 1 is equal to a outside of 0 squared plus b times 0 plus c. Now here we're in luck. C is equal to negative 1. So that's my third equation. I've got one of my variables. If I didn't, I would go on and solve all 3 of them simultaneously, but I've got one. So now I'm going to substitute C is equal to negative 1 into equation 1. Okay, so we get 6 equals A plus B, that's plus C, so that's negative 1. So that means 7 equals A plus B. And if I substitute it into my other equation, then I get 3 equals 4A minus 2B minus 1. And so therefore 4 equals 4A minus 2B, or 2 equals 2A minus B. Okay, now if I'm going to add those 2 equations together, then I end up with 9 is equal to 3A, so A equals 3, which I then substitute again. So I'm going to do the 7 equals A plus B just to make life easy. So 7 equals 3 plus B, and therefore B is equal to 4. Okay, so now I know what my A, my B, and my C are in that general form of the parabola. So therefore I can say that the parabola has the equation y equals 3x squared plus 4x minus 1. And that's why we use quadratic identities, because it can help us find the equation of a parabola when all we know are 3 of the points along it. Okay, that's what you need to do exercise 9.4. This is very heavy on the algebra, guys. So if you're really good at algebra, you don't need to do every question. But if it is something that you struggle with, then you'll need to do a bit more. So it's up to you. You do as much as you need, but make sure that you're really, really comfortable with it before you move on from this exercise. Good luck, and I'll see you in class.